Hello everyone. Today we're going to be talking about the states of matter. Now this time around we're doing our notes a little bit differently. Instead of doing a notebook for this unit, you are working at stations and you're going to have a packet for your stations. And at the end of the stations that's going to get turned in and that's going to be graded. So your notes are going to be a part of that station. So all you're going to need is a piece of paper, or two if you write big, a writing utensil, and possibly a highlighter to highlight any keywords or important information. We have a lot of new students in here with this set of notes. So for those of you that are unfamiliar with Cornell Notes, it is basically two columns. The larger column has basically all of the information from the notes. The smaller column is called a Q column or a question column, and you can write questions that relate to the topic. You can write key words, key points, things like that. And there should be an example at your station. If you are confused, don't be afraid to ask. You can ask another student, you can ask me. So don't be afraid to ask for help. Alright, so getting started. So today's notes, again, since we're not doing our notebook, we do not need a table of contents entry. Your title for the notes is going to be States of Matter. That should be at the top of your page. Below your title, you should have the essential question. And our essential question is, what is matter, and what makes each state of matter unique? Below the essential question, you should be setting it up similar to the picture on the screen. Two columns. And at the very end, we'll have a summary. Now, today's notes are a little bit long, so hang in there, keep at a good pace, and you should be all right. Okay, so matter. Matter is anything that takes up space. It's made up of atoms, and it makes up everything that's in the universe. So anything that we see, that we can touch, that we can feel, and even stuff that we can't necessarily see, like many gases, the air around us. It's matter. It's all made up of atoms, and everything in the universe is made up of that. Matter can be gases, it could be liquids, it could be solids, it can even be plasma, which we'll talk about in a little bit. So real quick, what are atoms? We're not going to focus a lot on them right now. We're going to come back to atoms with one of our next set of notes, and probably actually in our next unit. So you don't need to copy all of this information down, but you just need to be aware of the three key points here. Atoms are the smallest particles that make up all matter. They have kinetic energy, and kinetic energy is the energy of moving things. And also, all states of matter are made up of atoms. So that kind of ties into the first point. Atoms are smallest particles, they make up all matter, they have kinetic energy. That's what you need from this slide. Alright, so all matter can be found in one of four states. Now we usually refer to only the first three, which are solid, liquids, and gases. And we usually refer to just those because the fourth state of matter, plasma, is not very common on Earth. So we'll talk about that in a minute or two. So the first of the main states of matter is solids. Solids have particles with a very low kinetic energy. So what that means is they don't move around very much. They stay very closely together. They're packed very close. So they're bunched up right next to each other, and they don't move around a lot. They mostly just kind of vibrate in place. It's kind of like if you have a whole bunch of people packed together in a crowd. They can't really move around and walk around each other very much, but they might be able to, say, bounce up and down. That's kind of how the solids particles are. So they're packed very closely together, and they don't really move around. So this causes solids to have a fixed shape and volume. So they don't really change shape, they don't really change volume. All right, liquids. liquids also have a low kinetic energy, but they have more kinetic energy than solids do. So the particles can move around, but they're still staying very close together. So what happens with this is it causes liquids to have a fixed volume, so the volume stays the same, but it can take the shape of the container, so it doesn't have a fixed shape. Now the picture on the screen with the cats are a liquid. No, cats are not actually a liquid, it's just a joke. But liquids are able to take the shape of a container. And if you've ever seen a cat laying in a strange position or a strange location, you might see the similarity in how they can kind of take the shape of anything. So yes, it's just a joke. Alright, gases. Alright, now gases have a high level of kinetic energy. So this means the particles move around a lot. So they move away from each other. They want to get as far away from each other as possible, so they spread out as far as they can. So the shape and the volume can change because the particles can spread out as much as they are able to. So they will take the shape and volume of their container, whether it's a plastic bag or a bottle or a balloon or even the whole classroom. In our classroom, gases are spreading out as far as they can, and they're filling this whole room. So this whole room has particles in it in the air. So of the three main states of matter that we typically talk about, solids, liquids, gases, gases have the highest kinetic energy of those three. And these three are the ones we typically see on Earth. But there is a fourth state of matter, and that is called plasma. Now, plasma is actually the most common form of matter in the universe. Might be hard to believe because we actually don't see it very much on Earth. Examples of plasma on Earth would be things like fire, lightning. So it's not something we necessarily see a lot of, at least compared to things like solids, liquids, and gases. So in a plasma, the particles are moving so fast that they actually collide into each other and they break apart. And when they break apart, they form these little charged particles. So plasma actually has even more kinetic energy than gases do. And as you can see in the picture below the notes about the stars, stars actually make up about 99% of all the matter in the universe. That's a lot. And stars are made up of plasma. So almost all matter in the universe actually exists in the plasma state. So that's actually pretty amazing. It's not something we see a lot on Earth, but it actually does make up the majority of matter in the entire universe. Alright, now matter can change state. It doesn't have to stay a solid just because it's a solid at that moment. It can turn into a liquid, liquids can turn into gases, gases can turn into plasmas. And they can go back the other way as well. Liquids can turn to solids. So matter can change shape. However, there's two things matter can't do. It cannot be created out of nothing, and it cannot be completely destroyed. And we call this the law of conservation of matter. This is a really, really, really important law when it comes to chemistry and physics. You're going to hear about this law the whole time we're dealing with chemistry. So you're going to be hearing about this over and over again all the way into next semester. So this is definitely something to remember. So law of conservation of matter says matter can't be created, it can't be destroyed, but it can change form. So a change in state is just a change in the amount of energy in the particles, as you can see in the diagram below your notes. And you don't have to copy down the diagram. We're going to copy another slide real quick that's going to help you see what the changes are. Alright, so to change state, you either need to add energy or take energy away. Usually this energy is in the form of heat, but sometimes a change in pressure can also cause it, but it would have to be a really extreme change in pressure. So usually it's going to be adding or taking away heat. So the changes in state that require energy to be added, and what I mean by that is the particles, in order to make these changes, they need to have more kinetic energy, so they need to be able to move more. So melting is taking a solid to a liquid. Vaporization is taking a liquid to a gas. And then it is actually possible for a solid to go directly to a gas, completely skipping the liquid phase, and that is something called deposition. It's not very common, but it does happen. And again, these are changes that require energy to be added. Now, if you're taking energy away, your changes in state include freezing, which is liquid to solid, condensation, which is gas to liquid, and sublimation, which is basically the opposite of deposition, going from a gas directly to a solid, completely skipping that liquid state there. And that's it for our notes. You do need to write a summary at the end of your notes. So wherever you're at with your notes, you're going to go ahead and draw a line to cut it off. And then below it, you're going to write a short paragraph that just sums up the material from these notes that you just took. Those of you who have been here for a while, you should know that your summary should be about 3 to 5 sentences long. So make sure you are making it long enough. Make sure you include some key points, important information. Try to think about what you would tell someone if they weren't here for the notes and you're trying to explain the material for them. All right. Whenever you're done with this station, go ahead and staple your notes to your station's packet, and you can go ahead and move on to another station. All right, that's it.